In the rapidly evolving world of advanced semiconductors, Taiwan Semiconductor Manufacturing Company, widely known as TSMC, stands at the center of global technological progress. Its fabrication facilities produce the chips that power smartphones, data centers, artificial intelligence systems, and next-generation autonomous machines. Every major innovation in modern computing depends, in some way, on TSMC's manufacturing precision. From high-performance graphics processors to advanced AI accelerators, the company transforms complex chip designs into physical silicon reality with unmatched accuracy and consistency. Inside the fabrication plants, often referred to as fabs, the environment feels futuristic and meticulously controlled. Engineers wear full clean room suits as robotic systems glide silently across polished floors. Even a single particle of dust could damage a wafer, so air filtration systems operate continuously, maintaining near-perfect purity. The journey of a semiconductor begins with a pure silicon wafer. Through photolithography, ultraviolet light etches microscopic circuit patterns onto its surface. Layer by layer, intricate pathways are built using deposition and etching techniques, forming billions of transistors smaller than a fraction of a human hair. Artificial intelligence plays a growing role within the manufacturing process itself. Sensors collect enormous volumes of data at every stage. Machine learning systems analyze temperature variations, material stress levels, and alignment precision in real time, allowing engineers to make immediate corrections and maintain optimal yields. Automation and human expertise work in perfect harmony. Robotic arms transport wafers between stations with sub-micron precision, while engineers monitor performance dashboards that display defect rates, throughput speed, and production efficiency. This collaboration ensures reliability at a scale that serves the entire world. TSMC's advanced process nodes, including cutting-edge 3nm and upcoming 2nm technologies, represent years of research and billions of dollars in investment. Each generation reduces power consumption while dramatically increasing performance, enabling faster AI training, smoother gaming experiences, and more efficient cloud computing. Global technology leaders rely on TSMC's capabilities. Companies designing GPUs, CPUs, and AI processors depend on the company's consistent manufacturing standards to bring their most ambitious projects to life. Without this foundation, the modern digital ecosystem would struggle to function at its current scale. Beyond production, research and development laboratories continuously test new materials, transistor structures, and cooling innovations. Engineers simulate extreme workloads to predict how chips will perform in data centers, electric vehicles, and edge devices operating in challenging environments. Strategic planning sessions shape the company's future direction. Executives and engineers analyze global demand forecasts, geopolitical risks, and supply chain stability. Massive digital dashboards project manufacturing capacity years ahead, ensuring that innovation keeps pace with the accelerating demand for AI and computing power. Supply chains supporting semiconductor manufacturing are among the most complex in the world. Specialized chemicals, rare materials, and advanced machinery arrive from multiple countries. Yet within the controlled environment of the fabs, every component is synchronized into a seamless production flow. Quality assurance remains uncompromising. Each wafer undergoes extensive inspection before leaving the facility. Automated optical systems scan for microscopic irregularities, while electrical testing verifies transistor behavior. Only chips that meet the strictest performance benchmarks move forward for packaging and distribution. The impact of this precision manufacturing extends far beyond factory walls. AI researchers accelerate breakthroughs in medicine and climate modeling. Autonomous systems gain more accurate decision-making capabilities. High-performance computing clusters push the boundaries of scientific discovery. Even as automation advances, human insight remains essential. Engineers refine production techniques, optimize thermal management strategies, and innovate around power efficiency. Their expertise transforms complex engineering challenges into scalable solutions that power billions of devices worldwide. In essence, TSMC represents more than a manufacturing company. It embodies the convergence of science, engineering, strategy, and global collaboration. Every chip produced is a testament to precision, foresight, and the relentless pursuit of technological excellence. While TSMC operates behind the scenes, its influence stretches across every major technology brand on the planet. The world's most powerful companies depend on its precision manufacturing to turn their ambitious chip designs
The yield
into
projection
reality.
for the EUV line
Nvidia's
stabilized at
advanced AI
98.2%.
processors, used in data
Reworking the
centers and
anomaly
artificial
prediction for phase
intelligence
2.
research labs, rely heavily on TSMC's cutting-edge fabrication nodes. Without this manufacturing capability, the rapid evolution of AI acceleration would slow dramatically. Apple's custom-designed silicon chips powering iPhones, iPads, and Mac computers are also brought to life through TSMC's facilities. The performance efficiency that defines Apple's ecosystem is made possible by ultra-dense transistor technology produced with extreme ultraviolet lithography. Samsung, Qualcomm, AMD, and many other semiconductor innovators depend on the same advanced infrastructure. Even competitors in consumer electronics often share reliance on TSMC's fabrication strength, highlighting its central role in the global supply chain. This dependency creates a unique dynamic in the technology industry. Companies compete fiercely in design and performance, yet they converge at a single manufacturing powerhouse, capable of producing chips at nanometer scales with remarkable consistency. Inside executive boardrooms across Silicon Valley and Asia, strategic decisions often revolve around production capacity and fabrication timelines. Product launches, AI breakthroughs, and hardware upgrades all align with TSMC's manufacturing roadmap.
Analysis
As artificial
complete.
intelligence
The
models
AI
grow
metrics are
larger
stable
and more
and
complex,
operating at
demand
peak
for
efficiency.
advanced GPUs and specialized accelerators continues to surge. TSMC's ability to deliver higher transistor density and improved power efficiency directly shapes the speed of global innovation. Geopolitical considerations further amplify the company's importance. Governments recognize that semiconductor manufacturing is not just an industry, but a pillar of economic stability and national security. Investments, partnerships, and new fabrication plants reflect the strategic weight carried by advanced chip production.
We must
At the
secure
heart
the
of this
supply chain
ecosystem
now, before
lies
the
a
next
delicate
cycle.
balance
The
between
investment is
supply,
staggering.
demand,
We
and
need government
technological
support.
progress. A disruption in manufacturing capacity can ripple through industries, from smartphones and gaming consoles to cloud computing and autonomous vehicles. Yet despite this immense responsibility, the focus remains on innovation. Engineers continue refining transistor architectures, improving yield rates, and preparing for the next breakthrough node that will push computational limits even further. The collaboration between global chip designers and TSMC forms an invisible backbone of the digital world. Every app opened, every AI query processed, and every high-resolution video streamed carries the silent signature of advanced semiconductor fabrication. In the end, TSMC's role is both powerful and understated. It does not design the devices consumers hold in their hands, yet it enables their existence.
The yield metrics
It
on
does
this
not
batch
market
are exceeding
artificial
projections.
intelligence systems,
That
yet
aligns
it
with the new
builds the
calibration
silicon
settings we
foundation that
implemented.
makes them possible. As the world accelerates toward an AI-driven future, the importance of advanced semiconductor manufacturing will only grow stronger. And at the center of this transformation, TSMC remains a quiet but dominant force shaping the trajectory of global technology.